From making life possible on Earth, to keeping it warm and comfortable. The sun is the single, most important, part of the universe we live in. And even though it is so important, we still don't know many amazing things about our sun. This video shares a few such amazing facts. Welcome to Popular Science for All. The sun accounts for 99.8% of the mass of the solar system. And most of that final 0.2% comes from Jupiter. So the mass of the Earth is a fraction of the mass of the solar system. Really, we barely exist. If you could take apart the sun and pile up its different elements, you'd find that 74% of its mass comes from hydrogen, and 24% from helium. The remaining 2% includes trace amounts of iron, nickel, oxygen, and all the other elements we have in the solar system. In other words, the solar system is mostly made of hydrogen. We know of some amazingly large and bright stars, like Eta Carinae and Betelgeuse. But they're incredibly far away. Our own sun is a relatively bright star. If you could take the 50 closest stars within 17 light-years of the Earth, the sun would be the fourth brightest star in absolute terms. Not bad at all. With a diameter of 109 times the size of the Earth, the sun makes a really big sphere. You could fit 1.3 million Earths inside the sun. Or you can flatten out 11,990 Earths to cover the surface of the sun. Astronomers believe the sun and the planets formed from the solar nebula, around 4.59 billion years ago. The sun is in the main sequence stage right now, slowly using up its hydrogen fuel. In about 5 billion years the sun will enter the red giant phase, where it will swell up to consume the inner planets, including the Earth. It will shed its outer layers and shrink back down to a relatively tiny white dwarf star. This image is of the Sirius A and Sirius B taken by the Hubble Space Telescope. Sirius B, a white dwarf, can be seen as a faint point of light towards the lower left of the much brighter Sirius A. The sun actually has an internal structure. The visible surface is called the photosphere, and heats up to a temperature of about 6,000 degrees Kelvin. Beneath that is the convective zone, where heat moves slowly from the inner sun to the surface, and cooled material falls back down in columns. This region starts at 70% of the radius of the sun. Beneath the convection zone is the radiative zone. The core of the sun extends from the center to a distance of 0.2 solar radii, where temperatures reach 13.6 million degrees Kelvin, and molecules of hydrogen fuse into helium. Unlike the planets, the sun is a big sphere of hydrogen gas. Because of this, very interestingly, different parts of the sun rotate at different speeds. Scientists track the rotation of the sun by tracking the movement of sunspots across the surface. Regions at the equator take 25 days, poles take 36 days, while the inside of the sun takes about 27 days to complete one rotation. The surface of the sun reaches temperatures of 6,000 Kelvin. But this is actually much less than the sun's atmosphere. Above the surface of the sun is a region of the atmosphere called the chromosphere, where temperatures can reach 100,000 Kelvin. But even this is nothing compared to a distant region called the corona, which extends to a volume even larger than the sun itself. Temperatures in the corona can reach 1 million Kelvin. Well, that is it for today. We hope you enjoyed the video. Please don't forget to like, subscribe, and share this video. Until next time, God bless.